Thanks, Tracy. I just wanted to thank Paul and Glenn for the opportunity to speak this morning. The ramifications and the reverberations from Sandy from last October continue to bounce around not only the scientific community but the emergency management community, the climate change community. My area of expertise is more the here and now. I'm a meteorologist by profession. I leave Dave Phillips to talk about future decades, and I'm more worried about the weather over the next few days. But I did want to spend some time during the course of the presentation discussing these topics. The nature of Sandy, what made Sandy so special, what made the impact so large, advances in forecasting out into a longer time frame that we saw Sandy as a sort of a crystallization of a number of decades of improvement in the 3 to 10 day forecast, and we saw that realized with Sandy. And now the challenge that Environment Canada is going to have is to how to get information out in a longer time frame where we have meaningful information to share. So our response to Sandy, how we cooperated internally as a government department with other weather offices across eastern Canada, how we went about informing initially some key clients, but then getting out to a broader audience of the threat as Sandy approached. And then on the last point, where we see this going in the future. As we get more meaningful information into longer time frames, how are we going to express that? How are we going to talk about confidence and have people take meaningful actions in advance of storms of this nature? For anyone in the room, if there is questions, I'd be more than happy to answer them as they come up. And for anybody listening on WebEx, again, Glenn and Paul have my contact information. Any questions later on, I'd be more than happy to respond to as well. So when we talk about Sandy, the rarity, not so much for the fact that it combined elements of a big fall storm and a hurricane, but more the track it took as it came up the eastern seaboard and took a westward swing inland, and also the fact of just its massive size. And we'll talk about that in a little more detail in the next few slides. But to put a little bit of context into the discussion, Sandy began its life as a tropical cyclone, eventually becoming a hurricane. It was born of the processes that get the whole hurricane thing going, and it's totally different than the type of systems that we see forming over the mid-latitudes, the storm systems that normally affect much of Canada. So these tropical cyclones coming out of the tropics, no surprise, a variety of terminologies used, depressions, storms, hurricane and typhoon being interchangeable depending on what part of the world you're in. But the energy from these storm systems supplied by the very warm waters of the ocean. In these cases, we need 26 degrees Celsius or warmer water to get the process going that gets that cluster of thunderstorms forming, and then that cluster of thunderstorms eventually organizing itself into something more. Mature tropical cyclones with bands of rain wrapping around them, things that we've seen on television. The satellite image of what a hurricane looks like is very obvious. The most intense rain and wind with these systems in the eyewall area near the center of the storm. And they range in diameter from relatively small systems of only about 100 kilometers in diameter to well over 1,000 kilometers in diameter. And another one of their traits is they last for a number of days. So we do see clusters of thunderstorms form off the west coast of Africa on a regular basis in that sort of May to December time frame, but many of them will fall apart, not get the cohesion required to actually form into something more significant. The other important note about these tropical systems is the fact that once they form and they become significant, even if they become large, they're not actually really connected to the atmosphere around them. And the analogy that's been given is almost like a cork floating in a river. They are creating weather in their immediate surroundings, but not relying on weather around them or conditions around them to feed them. And again, stolen from my colleague Bob Robichaud's presentation that he does for ICLR every year as we lead into the hurricane season, what these systems look like. And I guess for those of you on WebEx, the traditional thing that we see here where the cursor is that shape of the hurricane itself is seen from space. The eye, that area of sinking air in the middle of the system that causes very warm and dry conditions right in the center of the storm, and then these spiral bands of showers and thunderstorms around that center, And again, the strongest winds that we're dealing with are right in that eye wall area, heaviest rain and strongest winds occurring in that area. So a series of upward motion, producing the storms, subsidence, drying things out, and then another band of thunderstorms going out in that spiral nature. Now, the other side of the equation are the types of storm systems that normally impact us here in Ontario, in the prairies, in Atlantic Canada, and these are extratropical cyclones. They are not born of the tropics. They don't rely on warm oceans to get them going. The driver for these extratropical cyclones are temperature contrasts in the horizontal. And so as the graphic shows, we start off with sort of a frontal boundary that separates warm air from cold air, and as the system evolves into a more notable warm front and cold front, we get that circulation going and the low pressure forms. But again, the intensity of these systems born over the mid-latitudes has more to do with this horizontal temperature contrast than ocean temperatures based in the tropics. The other thing to acknowledge is with tropical systems, the core of the storm is warm. That's the driver. That's where the energy is coming from. For these extratropical storms, these fall and winter storms that we see, the core of these storms are composed of cold air. So it's diametrically opposed in terms of the formation mechanisms and why these storms form. And instead of having the most intense rainfall around the eye wall area in a hurricane, the most intense rainfall with these extratropical systems tends to be along and just to the left of the way the track of the storm goes. Now, this is an example of one of these extratropical systems in what we call the traditional comma shape. And again, that comma shape is very obvious. The center of the storm over western Lake Superior, and we've got that comma shape of clouds down into the cold front down in this area. In this particular storm, the mid-Atlantic states and down through the southern U.S. But you'll note at least some similarities in that general shape. It still has a general spiral shape as the hurricane did, but the hurricane tending to be much more symmetrical, those bands spiraling around the center, whereas with the large mid-latitude extratropical systems, it's more of this comma shape, the low up in this area, and then this cold front down through here, and a warm front going off in this area. But the scope or the scale is still very similar. Some of these large fall and winter storms can easily cover and be much more in diameter than 1,500, 1,600 kilometers in diameter. Now, what's happening with about half of the hurricanes that form down off the west coast of Africa, down in the Caribbean, about half of these hurricanes will transition into a mid-latitude storm. We'll start to get some traits of storm systems that we see over the continent as opposed to those that form over the oceans. And so there's an interaction in many of these cases between the tropical cyclone and other weather systems surrounding that cork, no longer bobbing in the river on its own, but now starting to interact with the environment around it. And this results in a transition taking place that forms a new weather system, which can have components of both a hurricane and an extratropical cyclone. And even after a long period of time, even after this transition has already taken place, we can still find evidence of tropical characteristics buried inside some of these larger storms. So still maybe a warm core somewhere, an area of very unstable air still supporting a lot of thunderstorm activity, even though this transition has been completed for a long period of time. And it is also important to note that storms such as Sandy, which did transition from a hurricane to an extratropical cyclone or an extratropical storm, we see many of these events year to year in Canada or over the years. It wasn't so much the transition, again, that made Sandy unique. It was the way the transition occurred and the size of the storm and its relative slow motion that caused the impacts. Now, as a scientist, as a meteorologist, a climatologist, other atmospheric scientists, we've attempted to categorize storms into neat little pockets that we can put them into. But nature doesn't recognize any of these categories. So we talk about storms being tropical in nature or extratropical in nature, but there's a whole spectrum of storms somewhere in between. And that's really where Sandy fit. And Sandy didn't fit neatly into any one categorization, and that's why there's going to be probably debate for years to come as to when exactly Sandy transitioned from a full-fledged hurricane into an extratropical storm. It is also important to note the uniqueness of Sandy also because of where it made landfall. In the northeastern U.S., in looking online and reading some of the stories after Sandy, the recognition that about 20% of the U.S. population lived in the area that was impacted by Sandy. And also in terms of Canadian impacts, if we look at where this storm eventually tracked, and we'll see that a little later on in the presentation, impacts for very heavily populated areas of Canada as well, southern Ontario, southern Quebec, and the Atlantic provinces. So the lasting legacy, I think, for this particular event is that more effort in terms of research, in terms of the atmospheric science community, is likely going to put into to try to understand this transition process more, and again, these shades of gray as we talk about this storm not necessarily fitting into one or being pigeonholed into one category, trying to understand better the full spectrum of storms in these transition situations. This slide I thought was particularly useful. It looks at the track of tropical cyclones over the last number of years, since 1851 in the Atlantic Basin, since 1949 in the Pacific Basin. The deeper red areas then representing the more favored tracks of these storms over the last number of years. And you can see off the west coast of Africa, the birthplace of many of these systems, tracking westward, many of them curving northward along the Gulf Stream, some moving right into the Gulf of Mexico, and a much smaller number actually making landfall and moving inland over North America. So this truly was one of the things that made Sandy so rare, was that instead of following that track up along the Gulf Stream, perhaps having some more influence in Atlantic Canada, it actually made that left turn into New Jersey, coming inland towards the Great Lakes area. It has happened before. We've seen transitioning storms do it, both coming up from the Gulf of Mexico as well as coming in along the eastern seaboard of the U.S., but they don't happen all that often. And this then was the track that Sandy took. From early formation as a cluster of thunderstorms just north of South America, again, cluster of storms finally getting themselves together by the early morning hours of October 23rd, starting to attain tropical storm, then eventually hurricane status as it approached Jamaica, made its way up through after impacting Jamaica as a Category 2 hurricane in through Cuba, and then through the Bahamas as well as a Category 1 and 2, and then making its way again along the Gulf Stream. But we'll note, again, this track, sharp left turn as it comes up towards the eastern seaboard of the U.S., whereas many previous storms would have likely continued out over the Gulf Stream and had much less impact on the eastern seaboard of the U.S. and parts of Canada. A couple of images then taken from Sandy as it approached the eastern seaboard. This was midnight on October 29th, about a number of hours after this, 8 p.m. on that day was actually when Sandy made landfall. But we can already see by midnight on Monday, October 29th, the area denoted in red surrounding that circulation is the strongest wind. The deepest red, we're getting up to 70, 80 miles an hour. These are wind speeds of 110, 120 kilometers an hour. And again, the sense of the scale of these winds, how broad an area was being impacted by these areas in red denoting the very strong winds. But what we'll also note is already by midnight on October the 29th, some non-traditional, sort of non-hurricane-like features are being demonstrated. We'll notice that it isn't a symmetrical wind field around the center, around that eye, that we have stronger winds actually on the western part and the southern part, and somewhat weaker winds on the eastern and northern parts of the storm. So already this transition was beginning a number of hours before Sandy made landfall. Another image showing the scope of the storm. This was in the afternoon of Monday, October the 29th, about 6 hours before landfall was made in New Jersey. The coverage based, the folks at the Goddard Space Center from NASA, estimating 4.7 million square kilometers of territory being covered by Sandy. The center of circulation still off the coast, as we see here, but it was flinging moisture and cloud all the way up into the Ottawa Valley and northeastern Ontario. So even the clouds, excuse me, even the clouds up in this area, in parts of western Quebec, along the border with Ontario, was moisture and cloud associated with Sandy. So still a number of hours away from officially making landfall, but already influencing the weather across the eastern seaboard and parts of southern Canada. The other thing of note was in higher elevations where colder air had wrapped in around the storm, if we look back over West Virginia, parts of southern Pennsylvania, parts of northern Virginia, snow was falling. And in many cases, Canadians are always blamed for bad weather in the winter months in the U.S. because it's always cold Canadian air that comes down and brings them their miserable conditions in the heart of winter. In this particular case, again, about 6 hours from landfall, we were already seeing interaction with a large area of high pressure over Quebec, helping to steer it inland, and cold air and a frontal system moving in from the American Midwest, interacting with Sandy. So again, this transition, moving away from just a totally tropical hurricane situation into something that was becoming combined with a large-scale fall storm. Yet another example where the deep blue shades indicate cold cloud top temperatures. Again, still a number of hours before landfall. This was Monday afternoon, October 29th again. The center of the storm indicated by the coldest tops here, these purples indicated just off the coast, but the deep blues also indicating high-level clouds that have been flung off from the center of Sandy and had moved well inland. So already again over parts of southern Ontario, western Quebec, into the Great Lakes area, Lake Huron, Georgian Bay, and lower Michigan. So the storm itself still, the center of it, off the coast, and yet impacts from it being felt well inland. The interaction of other weather systems. We talked about when a hurricane is truly a hurricane, it's that cork bobbing in the river, not a lot of interaction with the surrounding atmosphere, but by the time, and this was again a landfall occurring at 8 o'clock in the evening on Monday, October 29, intense systems, so the central pressure down to 945 millibars are analyzed here, one of the lowest pressures we've seen in that part of the world ever. But the interaction with other systems, so a frontal feature over the Great Lakes area, a large area of high pressure north of Labrador. The circulation around that high is clockwise, so we're bringing sort of the winds, steering the system inland, and then as it pushed inland, interacting with that colder air as it transitioned into a storm system, but again with still embedded characteristics of a hurricane. A few of the features then, as Sandy made landfall, at its lowest central pressure, the way we measure the intensity of these systems, it was recorded as 940 millibars. And to give you a sense of normal low-pressure systems that go through may have a central pressure of, say, 990, 995 millibars. This was a very low central pressure, setting up a very large wind field around the system. The massive size of the combined both elements of hurricane and fall storm, affecting a diameter of over 1,600 kilometers at one point. The storm surge, where unfortunately Sandy making landfall that coincided with high tide. So already the tide was moving in. We had winds pushing those body of water further inland as well. So a surge recorded, which was a record for New York City itself, of 4.2 meters. There was also a 10-meter wave recorded in New York Harbor, in and above this surge that was happening. Also to touch on the multiple elements that this storm was bringing in severe levels. High winds, record surge, significant amounts of rain along the eastern seaboard of the U.S. As we mentioned earlier, in some parts, 2 to 3 feet of snow falling in higher elevations in West Virginia, southern Pennsylvania, and parts of northern Virginia. The loss estimates bouncing around on the internet, they're still all over the place. Started out at about 25 billion, but we've now heard estimates of 50 billion. I've seen estimates of 60 billion. I think it's going to be some time before we fully understand what the losses were from this particular event in the U.S. This series of images then goes from the afternoon hours of Monday the 29th right through the 30th to give a sense of how slow the system moved and the scale of its impact. So again, these number of lines, these isobars, lines of constant pressure, the more closely packed these lines are indicative of strong winds. The circulation is counterclockwise around these areas of low pressure. So by the time we get over southern Ontario, the areas in red, we're indicating where wind warnings are in effect. It's basically a north wind coming down into southern Ontario. That was our concern. Knowing it was going to be a north wind, particular vulnerabilities along the southern shores of Lake Huron, where there would be a long fetch or a long period of travel of those strong winds over the lake with very little friction. Also concerns of strong wind damage along the southern shores of Lake Erie and the southern shores of Lake Ontario. So Niagara Peninsula, another area that we were concerned about in terms of potential impacts from this system. So this is still a few hours before actual landfall. The warnings have been posted in Canada in these areas in anticipation of that event. Moving forward, we're still a little bit away from landfall. Again, the storm system moving a little bit closer. This is late afternoon on Monday the 29th. This is now landfall. This is about 8 o'clock in the evening on the 29th. Again, we'll notice even more intense, more tightly packed isobars in these areas here, Pennsylvania, all the way into southern Ontario. Very strong wind gusts out of the north and northeast in these areas during this time. This is about the time frame the winds really started to pick up in southern Ontario, and we started seeing gusts across a number of locations up to 80 kilometers an hour, and even stronger gusts, again, along that south shore of Lake Huron into Lambton County. Now it has made landfall. It's moving onshore, but it's not moving very quickly. So the impacts it was having in terms of rain and snow and wind, surge still to a lesser extent, but still happening. This is still an issue as we move through those late evening and early overnight hours into the 30th. And again, continues to move inland, and again. And so now here we are in the morning of October 30th. We're noticing it is weakening. The central pressure is filling to higher values, now 982 millibars. The wind field itself still appreciable, but it is starting to drop off. And really the only area that still had a wind warning in effect by the morning of Tuesday the 30th was down in the Sarnia and Lambton area, with again the concerns of that wind coming out of the north right into that area across Lake Huron. And by this time, it's no longer, it's still got some remnants of a hurricane left in it, so remnants of its moisture and energy, but it now has fully transitioned into that mid-latitude or extratropical storm. And now we're seeing thunderstorm activity. This is real-time lightning showing up just off the coast. So this activity here is real-time lightning that was occurring, so still thunderstorms associated with Sandy. We're still dealing with warnings up in the northeastern parts of the province as well, and also along the St. Lawrence Valley. So the scope of this system, even in through that Tuesday morning on the 30th, was still quite large, and warnings still out for Atlantic Canada, thunderstorm activity still occurring, and that activity continued during the morning hours on the 30th and even into the early afternoon hours. So by this point, this is around midday on Tuesday the 30th, we see it's transitioned almost the center of it, almost into Erie, Pennsylvania, towards Lake Erie. The wind field's kind of pushed off and weakened somewhat, and still for Atlantic Canada, parts of the upper St. Lawrence and Quebec, impacts were still being felt from this system. So slow-moving nature, the scope of the system, and the fact that it still had cocooned or embedded inside of it some elements of its tropical nature, all conspired to continue to have impacts, again, over this large geographic area. And then again, just continuing this activity, even some thunderstorm activity in the Ottawa Valley on the afternoon of the 30th as well. The imagery, huge numbers of available images on the internet to choose from. Important to note that there were significant impacts when it was a true hurricane down in the Caribbean, in Jamaica, and in Cuba, and in parts of the Bahamas. Other impacts, obviously from wind, the trees coming down, power outages, flooding in parts of New York, and a big impact for New York City, flooding of parts of the subway system. For a city the size of New York, the subway moves people around. It gets them where they have to go, and when sections of that subway were knocked out, even after people were sort of settled their home lives, were able to return to work, a number of them found it difficult to get to work because that arterial system, the way to move those people around, was still impacted. And trying to run buses in New York to replace the subway was a non-starter. These buses were packed. There was a lot of confusion, pushing and shoving. So lasting impacts from the fact until they could get the subway dried out and operational again. We also heard stories of folks trapped in areas near the shoreline, high-rise buildings, no power for long periods of time. People expected to walk up and down 17 flights of stairs with water just to have the necessities of life. Shut-ins, elderly, people that had mobility issues, literally trapped in their apartments in these multi-story buildings for days on end, and without the help of neighbors, could have been in very serious trouble. The fuel situation in New York for the longest time, again, affected by power, the inability to get trucks to replenish the tanks in some of these areas, and that was a long-lasting impact as well. Long after Sandy had ended, they were still dealing with the ramifications of lack of fuel, lack of power, and some issues with basic infrastructure. In Canada, especially in Ontario, again, similar impact with respect to the trees, but nowhere near the same number coming down. So we did have some damage, secondary damage to vehicles and homes as some of these trees came down. The tragedy of the woman killed here in Toronto being struck by a piece of a Staples sign, ironically, as she was going to Staples to buy batteries because she knew the storm was coming. And that, unfortunately, was the last thing that she did. So this thing, again, the winds at this point when the sign actually gave way in Toronto, not even the strongest. So some question as to the sign not being properly fastened even before the storm came. And so when this thing finally did give way, we weren't necessarily talking about 90-kilometer-an-hour winds. It may have only been winds of 60 or 70 kilometers an hour that eventually caused that sign to give way and kill the unfortunate woman. Other Ontario impacts, we talked about the wind direction being significant, coming from the north, right down the axis of Lake Huron. The main concern then, Sarnia and Lambton, and that was the area that ended up getting the strongest winds for the longest period of time. Many areas in southern Ontario, wind gusts to 80 or 90 kilometers an hour, causing the impacts that we saw, but even stronger winds, consistent gusts to 95, 100 kilometers an hour in Sarnia and Lambton County, so even more notable damage in that county and in that city. 2 fatalities, the Toronto woman that we've talked about, and Blue Water Power having one of its employees killed, repairing down power lines in the aftermath. At one point, up to 150,000 people in southern Ontario without power, about 50,000 of that in and around the GTA. And other economic impacts that maybe don't strike one right away that I was told of by a radio reporter in the Windsor area who went down on the evening of the 29th to the western shore of Lake Erie to see literally dozens of Lakers staying at the west end of Lake Erie because they were experiencing 7-meter waves at the south end of Lake Huron. It wasn't safe for the Lakers to transition up through Lake St. Clair and get into the south end of Lake Huron because these waves were basically coming from north to south down the long axis of the lake. So she literally said it looked like a city of lights out over the west end of Lake Erie as these Lakers waited for the winds to abate, the waves to die down a bit so they could transition up into the upper Great Lakes and continue on with their responsibilities. And again, we know economically very difficult these days for the Lakers to make a lot of money, so these delays caused by having to wait the storm out, again, exacerbated that situation. Now, advances in forecasting, which has been both a positive and a challenge for those of us in Environment Canada. In the last 25 years or so, we've seen a huge increase in the capability of computers to perform so many calculations per second. And some of the most powerful supercomputers now are capable of doing 70 trillion calculations per second. The ability for these computers to do more calculations allows us to have more accurate estimations of the future state of the atmosphere. So again, a better ability to approximate what's going on in the atmosphere currently and what will be going on in the atmosphere in coming days. Ensemble type forecasting, which is basically taking a computer model, slightly changing the initial conditions, and then running multiple versions of that model to see different weather maps come out. Forecasters now becoming adept at looking at these ensemble spaghetti plots, as they call them, showing different tracks based on different initial conditions. Is the model merging towards one solution? Is there a particular outlier that has some significance? So we're getting better at using this, again, ensemble approach, multiple versions of that model with slightly different initial conditions to see how stable or unstable the solutions are coming out of those computer models. And in looking back in terms of accuracy, our forecast for tomorrow is now as accurate as our forecast for the present day was about 25 years ago. Our forecast for 7 days out into the future is about as accurate as our forecast was out to 5 days 25 years ago. So again, increases in computer power, better weather models, so the researchers are able to use that increased power to better simulate the atmosphere, and that's resulting in more confidence in these forecasts to a longer time frame out into the future. This also has implications for increased safety and economic benefits, as a number of parts of our economy would look to the increased ability of these forecasts to increase their profitability as well as the safety margin for society. So aviation, agriculture, tourism, the retail industry, utilities will all now start be looking to use this better information out into a longer time frame for planning purposes and for activities in their area that would be weather dependent. This is an example then of this ensemble approach. This was a spaghetti plot, if you will, showing a series of potential storm tracks for Sandy 7.5 days before Sandy made landfall on October the 29th. The European Center for Medium Range Weather Forecast has the world's fastest computer for weather forecasting. They dedicated that forecasting model to the medium range forecast, 3 to 10 days into the future, and in many of these situations has seemed to be the superior model in terms of how these events actually occurred. If we notice the varied number of colored lines, these were the various solutions the model was coming up with 7.5 days in advance, and the black line indicating the actual track that Sandy took. So we can note, again, as you move forward in time, we start to see the tracks spread out more, and eventually as we get further and further in time, those tracks spread out even more. But a number of the solutions, even 7.5 days into the future, were indicating this relatively rare westward turn inland towards the Great Lakes. And it was at this point that forecasters in the U.S. and in Canada started having a discussion about if this track does in fact come to pass, what could the implications be all along the eastern seaboard of the U.S. and in portions of eastern Canada. So this has allowed us, again, increased accuracy in the longer range, introduces the challenge again of how to impart this information. There is still a relatively low confidence in some of these forecasts. We're not quite sure it's going to pan out, but again, with Sandy, that particular model seemed to be fairly confident it was going to make that westward turn. It works best with large and well-defined weather systems. We're talking about forecasts that far into the future. So smaller scale storms, those individual thunderstorms that may spawn tornadoes, this is still something that we're going to need to develop, and we're not really capable at this point to get that kind of accuracy 5, 6, 7 days into the future for more summer-type storms. Some situations, even with the larger well-defined systems, still are low-confidence situations. So we may keep to ourselves, in some cases, situations where that spaghetti plot is really spread out, where there's no real consistent solution showing up, and maybe wait to get closer to the event before we start informing partners or the public of the potential for that storm. Now, with respect to Environment Canada's response to Sandy, this is the map, again, that Bob Robichaud uses in his briefing every year for ICLR to talk about the hurricane season. So from a Canadian perspective, the Canadian Hurricane Center in Dartmouth, the shaded-in area and the bold area, again, their area of responsibility for storms. And then the thin red line, the response zone, is when they would start opening up the Hurricane Center because a storm has entered that response area that may impact some part of Canada. With respect to forecasting within the individual provinces and regions of the country, co-located with the Canadian Hurricane Center in Dartmouth is the Forecast Center for Nova Scotia, New Brunswick, and Prince Edward Island. Located in Montreal is the Forecast Center responsible for Quebec, and our Forecast Center here in Toronto at Dufferin and Steeles is responsible for forecasting in Ontario. As it became apparent in each of the 3 or 4 offices that we would potentially have a big issue to deal with Sandy, that's when coordination started to take place between the 3 offices to get coherent and consistent messaging. We didn't want somebody quoted in a radio story out of Dartmouth that Sandy was going to stay out over the Atlantic and have someone like myself do that radio interview and say, we're concerned that Sandy's going to turn inland and may be a problem for Ontario. So interregional coordination started about a week before. October 22nd, 23rd was when those conversations began. The issues we face then with this early notification, we've got to sense something could be happening, confidence is growing. When, how, and who do we tell about these approaching storms? We're not ready yet to share it with the public, but probably some key partners within government, municipalities, regional governments, emergency responders, they should start to be informed. How do we express confidence level in these longer range forecasts? We need to develop a vocabulary that lets them know we feel fairly strongly this is going to happen, or basically this is a tap on the shoulder for a maybe event. We're not quite sure, but we thought that you should know about it. And then how do we ensure the message and the risks are properly understood? This is an ongoing challenge for every weather service in the world. The Americans are dealing with it to do with tornadoes. In the recent summer severe weather season, the Americans experimented with using much stronger language. When they had higher confidence about a tornado's capability to kill, they would actually say this tornado has a potential to be deadly, using that stronger language. So this is something that we're going to be experimenting with during the course of the coming months and years. So internal discussions were held within Environment Canada offices on October 23rd about potential impacts about a week away, 6 days away. At that point, on the afternoon of October 23rd, an email was sent by my colleague, Peter Kimball, Warning Preparedness Meteorologist in Ottawa, to key emergency management clients at the provincial level. The Surface Water Monitoring Centre in Peterborough, when originally we thought rain would be an issue as well, the Fire Weather Centre in Sault Ste. Marie, which is the provincial weather centre, and Emergency Management Ontario, all brought on board at this stage to let them know of a potential issue. Additional emails then sent out the following day on Wednesday the 24th to an expanded list of clients. We're bringing in now conservation authorities, more clients in other provincial ministries, more clients in a regional and municipal government sense. And then finally, the first real public notification, the evening on October 25th, Thursday evening, this was a tropical cyclone statement issued from the Canadian Hurricane Centre mentioning Sandy, mentioning potential impact for southern Ontario, southern Quebec, and Atlantic Canada. Continuing along this, now on October 26th, on the Friday, before Sandy was expected to hit on that following Monday evening, conference calls more frequently between the regions to coordinate information. Special weather statements sent from the Storm Prediction Centre here in Toronto talking about specific Ontario impacts. That went out on the afternoon of Friday, October the 26th. So again, talking about an event that still wasn't going to happen for another 3 days or so. At that time, there was a concern for both rain and wind, but as we got closer to the event, the rain side of it tended to drop off. Special media and emergency management manager conference calls were held on the Saturday, Sunday, and Monday. So Saturday the 27th, Sunday the 28th, and Monday the 29th, at certain scheduled times, there was a technical briefing for emergency managers across Eastern Canada, and special national media conferences handled by the Canadian Hurricane Centre with backup by spokespeople in Montreal and in Toronto. Extra staffing was brought into the weather centres on the Saturday and Sunday in the lead-up, as well as additional media spokespeople. My colleagues Peter and Etienne in Ottawa, one works Saturday and one works Sunday to handle the increased media workload. Continuing coordination of the messaging between the regions, and again bringing in the conservation authorities because of the concern that we may be dealing with significant rainfalls. By 4:50 a.m. on the morning of Monday, October the 29th, the first warning went out for Ontario. It was a wind warning, and it was talking about winds increasing by late afternoon or evening, so about a 12 to 15-hour lead time on the wind warning, covering much of southwestern and south central Ontario underneath this warning. The rain no longer expected to be as significant, and so it was dropped, and the wind warning was the main mechanism that we got the word out about Sandy. Emergency Management Ontario coordinated a conference call with other provincial ministries, and Environment Canada was asked to provide a weather briefing for that. EMO, in concert with the Provincial Ministry of Transportation, changed the messaging on a number of the electronic signs along the 400 series highways and some of the other highways, mentioning wind warning in effect, or wind warning for this evening, so again, getting the word out in another mechanism. And at about 8 o'clock in the evening on Monday the 29th, we really started to see these winds picking up out of the north across southern Ontario. In the aftermath, so the winds really strong Monday evening, strong into Tuesday morning, starting to drop off after that. Some of the reaction I dealt with then on the Tuesday was they woke up, people looked outside, their trees were still standing, they weren't flooded out. Boy, it didn't seem so bad, Geoff. Didn't you guys overdo this? I mean, the messaging was pretty strong. But what we're finding in our society, and I kind of mixed it up here in the slide here, but we're blending everything now. there's a constant onslaught of information that's available to anybody at any time. Everybody has a computer now at their disposal. A tablet, smartphone, desktop, laptop. You can consume information from any source you choose. And in a lot of cases, what I was dealing with was, in people's minds, it was Anderson Cooper tied to a lamppost being blown around in New Jersey. Why am I not getting that, Geoff? Isn't that what I was supposed to get? So we were having to separate out the messaging Environment Canada issued from the very appropriate and much more strongly worded messaging of the National Weather Service for those areas along the eastern seaboard. But everybody had been caught up. Every news channel was broadcasting Sandy information almost nonstop, and it was easy to confuse what we had thought would happen on the eastern seaboard, which did come to pass, with what we thought would happen in southern Ontario, which would be lesser impacts, though we still did expect some. And so this idea of traditional media and social media and media on demand, it's blurring geography and it's blurring the message. And we're finding our distinct message maybe being lost a little bit in this massive inundation of words and tweets and Facebook postings and what have you. So another challenge for us to, again, keep our messaging distinct, make sure people understand it in their specific area. These are the impacts that we expect. I think I broke. So the future then, lessons learned from Sandy, what we thought worked well, what we thought didn't, things that we'd like to do differently. Well, there's a couple of things we're hoping to roll out at some point in 2013. The top one called ICLR, which would be a way for anyone basically to sign up to receive our Environment Canada alerts by email or text message. We have a system right now that provides emails of our bulletins to a select group of emergency management, media, and some other key clients, but it is a full email. It's a very long message, and ICLR will then give the client much more flexibility in terms of choosing which alerts to get and the method with which they get delivered. Another thing we're working on is more focused warnings where we try to provide context, perhaps historically. This could be the worst outbreak of thunderstorms for the last 5 years. This could be the worst freezing rain event in the last 10 years. So impact-based as well, so that we are expecting widespread power failure. We're expecting the road system to be a mess. There will be impacts on aviation travel. So using wording that will perhaps relate the storm more to the everyday person so they can get a sense of how bad we think it's going to be. This idea of when to alert the media and the public. How far into the future should we be mentioning these things when in many cases they may not come to pass? And we're sort of using up our credibility by sending out these early notifications when things don't pan out. So again, key clients, we're probably going to keep on doing this, but we still need to discuss when we're going to start sending these messages to a broader audience. And last but not least, how to alert. And studies continue in the U.S. and Canada, and Europe as well. What's the best way to get information to people, and what's the best way to ensure that they understand it and react to it appropriately. So ICLR Me will be a user configurable system. You'll have your own account, your own password. You'll choose the type of warnings that you're interested in. You have the ability to receive only the initial message and the end message. One of our biggest complaints of the current email system is on a busy summer afternoon, we may update the warnings on a regular and frequent basis, and it can flood people's inboxes. And really what a lot of our emergency management clients are saying, I'm busy, my inbox is important to me, and you guys are just drowning me. So with ICLR, you'll be able to just get the first message. It's new for your area, you should know this, and the last message. The thread is now over. All the updates in between, if you want to get them, there's still that ability, but for some of our clients, it's just tell me when it's going to come, tell me when it's over. Messages will contain a link to a map showing additional details and warning areas. So for clients who want the information in a text, 140 characters, freezing rain warning for your area, click here for more details. So they get the tap on the shoulder. If they can't pull over to the side of the road and look at the more information right away, at least they know when they get to where they're going, they can fire up their laptop, they can go on their smartphone, click on that hyperlink, and pull out more information. And so what the site will look like is a login screen. This is the mock-up right now. You'll have an email address as your account. You'll set up your own password. Once you're in the system, you'll have a menu on the left-hand side. that will allow you to manage your account, make changes to it. It will also show the most recent alerts for a series of your areas. Sorry, thanks. For a series of your areas. In my test account, I created 3 regions. I call Geoff 1, Geoff 2, Geoff 3, but you could set up accounts that have meaning geographically. You could set up southwestern Ontario, eastern Ontario, North Bay Sudbury, for example. Give these meaningful names so that when you get the alert in a text sense, frost warning ended for Geoff 2, well, it could say frost warning ended for eastern Ontario. So you have the capability to name parts of the province or parts of the country that you want the alerts for and have these alerts be more meaningful. Once the alert comes in these cases, a series of text messages, you've got the View More hyperlink to go and dig deeper and find out more details on that particular alert. On the screen management side, in terms of managing your account, you can see here areas I've subscribed to under the Geoff 1 account, the active alerts I'm interested in, so I basically ask for all the types of warnings that Environment Canada sends. But what we can actually do is you can pick and choose particular ones of interest and not get alerted for every single one. This account has been set up so that I get every message, the issuance, the end message, the upgrades and downgrades and continuations. But again, if you're a client that just wants that first message and that last message, you can just ask for the issuance and the end message, and that's all you'll get for your subscribed area. So a lot of flexibility in terms of this account. What these things look like then, the email, a little bit more in the way of detail in the email. It's telling what the event is, which area it's in effect for. The alert is for Geoff 1, which is the area I have around Toronto and down into the southwest. And as you'll see here, the hyperlink says more details on the alert are available here. By clicking on that, you'll get the map showing where the warning is in effect for and more details on that warning. The text message, because of the restriction on the number of characters, is right to the point. Rainfall warning issued for Geoff 1. Geoff 1 is my area in extreme southwestern Ontario. Again, that could be changed to whatever is more meaningful to you. Issued on September 4th. Right now it's in universal time. By the time this hits the real world, we'll probably change that to local time. But again, you've got that View More hyperlink. By clicking on that, you can get more information on that particular warning. Now, in terms of risk communication, impact-based warnings, trying to have more meaningful warnings, more focused warnings. Right now, what we've got is basically a system where there's no warning or we have a warning of some type: rainfall, snowfall, wind, severe thunderstorm. Something we'd like to propose to move towards, something that they've used in France for the last 8 years or so, something they've used in the UK for the last 6 or 7 years, is a more impact-based or tier type of system where green represents no impact weather, general weather. Yellow is our current level threshold for whatever that warning is, so there will be some impacts. Orange, perhaps the worst of that event in the season, so there will be more notable impacts. And then a red level event, we're talking about a rare event, perhaps a 1 in 10-year event that we really want to get people's attention up. So by and large, most of our events would probably be yellow. We may get a few oranges each year, and a red would only occur once every few years, depending on the type of weather that we're talking about. As we move up the scale from green to yellow to orange to red, we notice we're also moving along the scale of frequent occurrence to something that's much more rare, but also presents more vulnerabilities and more potential for impacts and damage to the community. As we move up the scale from yellow to orange to red, we need to bring in knowledge from other areas of expertise. We need to have a better understanding of the role of antecedent conditions, especially for flooding situations in the summer months. If that watershed is already very moist, has a lot of water in the watershed, and we're adding another 100 millimeters in a sensitive part of it, we could have bigger impacts than in an area that's seen a drier summer up to that point. Better risk and hazard explanation, so again, more details on exactly what we think the threat is and the impacts will be, and even going to the extent as the Americans did this past summer and offering behavioral advice. You need to get into shelter now. Provide that immediacy when the confidence is there. And that's really where the challenge is, because in many cases, as the system is developing, we may not yet have the confidence to make these strident remarks, but as the event evolves, we may see it move up the scale from yellow to orange, and we want to have stronger language in the wording to accompany it. So as we mentioned, green would be sort of a normal level of monitoring. Yellow would be the current warning criteria, whatever it may be, a snow squall, freezing rain, that level has been crossed. Orange, a more significant event, it's a more rare event, but will have more impact, so once a season type event. And then red, rare, particularly dangerous, once in a decade type of storm. And the real concern, and we've seen it from the living laboratory of France for the last 8 years, is truly restricting that color red when you have high confidence of high impact. If this color is used for events that don't pan out, you've lost that capital you've built up with the public, and you have less chance they're going to react as you want them to for the next red event. So real care on the part of forecasters when they're moving, especially from orange to red, to ensure that that confidence is there. The warning impact statements themselves, what we're going to find in the body of the warning then will be more directly linked to the level of the message. Stronger wording and more specific wording as we move up from yellow to orange to red. Strong tornadoes today could cause serious injury or death. Intense snow squalls causing zero visibilities and extremely dangerous driving conditions. Trying to use words that will strike home to people will get them to change behaviors, which continues to be a big challenge. The combination of freezing rain and high winds will result in widespread power failures in eastern Ontario later on today. So again, to give folks the idea that there is a requirement to prepare, they could be dealing with a situation of extended power outages and to take appropriate precautions. So for the summer of 2013, we're going to begin our changes with the severe thunderstorm and tornado warning suite of bulletins. We're going to be looking for more specific impact messages related to the type of weather we expect with that thunderstorm. If it's just damaging winds, that will be emphasized. If it's just hail, if it's just heavy rain, or if it's a tornado. If it's a supercell storm capable of producing all four, then that would be mentioned as well. Try to focus in the geography a bit better, using more place names that people can identify with. The regions now, even at their smallest extent, are still fairly large compared to the scale of our summer storm. So we want to try to focus in and really tell people it's Harrow and Leamington in Essex County that are at risk today, and areas closer to Lambton County, the storms are not going to impact you. Building on what we do this summer, also looking to begin this process for the fall and winter of 2013. Again, more specific messaging, focused messaging, and again, impact-based as much as possible. And this whole thing will be continue to be assessed and fine-tuned based on client feedback from our key stakeholders, from the public, from the media. Is our message getting out? Is our message being understood? And then we'll make tweaks as required. So once again, I wanted to thank Paul and Glenn for the opportunity to present this morning, and I'd be happy to answer any questions that anyone may have.
One thing I noted this past summer that was different to me was lots of warnings about potential for water spouts. Is that new, or is that just the weather that we experienced this past summer?
Part of it is a better understanding of the formative mechanisms and also a much better reporting system. With social media now, we actually set a record last year for the most water spouts ever recorded. We've been monitoring the water spout numbers since about 1995 in a close sense. We had something like 156 water spouts on the Great Lakes this year. The previous record was like 96. We have a public that's more aware. So are these water spouts happening more frequently, or are we just getting folks knowing where to send that picture from their smartphone into the National Weather Service or Environment Canada? So on our part, once we're getting corroboration, we have a system to assess days for the potential for water spout formation. But oftentimes they'll wait for that first report to say, okay, these things are actually now forming. Once that report comes in, and as you said, you're hearing it in the marine community more often, and also in terms of special weather statements for areas near the Great Lakes. A true water spout will die as it moves inland. It needs the warm water to live. The concern, though, is something like the Goderich tornado, which was a supercell water spout when it was born. It was a massive, severe thunderstorm over the water. But by and large, the vast majority of water spouts we see are kind of a weaker cousin that form over the lake and will die once they come very far inland. So I think it's part and parcel of this social media explosion. Everybody wants to share, everybody wants to be famous for 15 minutes, and there is a beneficial effect that some of these reports are gold to the National Weather Service and Environment Canada.
With the losses from Sandy that were experienced, most of the $50 billion were in the U.S., not so much here in Canada. I remember sitting at one meeting around the table with a number of Canadian insurers saying, gee, my losses were in Sarnia, and it just seemed very peculiar that we got this big hurricane for way through, and why would Sarnia show up? And your material you shared today said that you were anticipating Sarnia. It stood out in terms of some of what you saw coming. But what was it about Sandy that led to damage in Sarnia? And is that something, what happened there?
Yeah, really the big story for Sarnia and Lambton County was the direction the winds were coming from. In many of the wind events that we get on a large scale associated with a big storm system, our damaging winds are coming from the northwest or the west at the back end of the storm as it moves through. Because Sandy was unique in some respects, coming up out of the south, we were in the northern part of the wind field. Sarnia and Lambton County situated at the bottom of Lake Huron. So what you've got is these very strong winds passing over a relatively frictionless surface, which is the water of Lake Huron, and then impacting that shoreline with additional ferocity to areas, say, further inland, Dufferin County, Kitchener, where that wind has to, again, go over rougher terrain. It's not as strong by the time it gets to these further inland areas. So because portions of Lambton County, Sarnia itself, right on the lakefront, at the end of a long fetch or a long passage of that north wind, they were the ones that were getting the strongest wind gusts consistently. Winds had died down by Tuesday morning, the 30th, in most of southern Ontario, about 60 kilometers an hour, but they continued to gust about 95 kilometers an hour till late in the afternoon on Tuesday the 30th in Sarnia and Lambton County, again because of that effect, the reduced friction, long passage over the water, and then bang, right into the shore.
A different question about Sandy and why Sandy had some of its characteristics. There was some reflection as it was approaching to Hazel, and Hazel had a remarkable shock effect on Canada, and especially this part of Canada. And some of what we saw from Sandy in the U.S. were water damage, and Hazel was more water than wind damage. And you were sharing some of the expectation that Sandy was approaching was for water and wind,
right.
But as it actually arrived on the Canadian side of things, it had less of the water than in the U.S. or than things like Hazel in the past had in Canada. Why was there not as much water in Canada from Sandy?
What we saw was, I think, the interaction of Sandy with the weather system that was over the continent concentrated the heaviest rain and snow to within a few hundred miles of the seaboard itself. So we still did see spiral bands of showers and some thunderstorms make its way into southern Quebec and southern Ontario, but it didn't have the deep moisture that was occurring right close to the seaboard itself. Now, what happened with Hazel was Hazel managed to bring with it inland, very far inland, most of its tropical characteristics. A lot of that moisture stayed with Hazel as it worked its way inland, and then Hazel interacted with another system which had its own moisture feed, and that led to the tragedy of huge amounts of rain falling in a short period of time, houses floating along the Humber and stuff as they were ripped from their foundations. But with Sandy, we saw as it made landfall, it really concentrated that moisture and that rain along the seaboard, and whatever wrapped northwards towards us was notably weakened for what was happening right along the coast, which is another example of how each of these systems has their own characteristics. We can say with Hazel, the track looked a little similar when we saw it like 7 days in advance, but as it evolved, as it got closer and as it actually transpired, it had its own unique characteristics that differentiated it from Hazel to a large extent. Fortunately for us, because if we had got some of that rain, some of the parts of southern Ontario were sensitive to 50 to 100 mils in a short period of time.
Can you just explain, I'm a little not clear on this, what exactly is a storm surge? What is it? What is it caused by?
So normally we've got the ocean, which is kind of at a certain level, and you've got waves on top of that, the winds blow and what have you. But with a hurricane, what you're actually getting is a force pushing, literally pushing a wall of water ahead of it. Because it rotates counterclockwise around that center, so the north side is sort of pushing this wall of water with these consistent winds that come out of the east. As it made landfall, what was then happening was we had high tide, so normally the water's here, at high tide it's up here, and then Sandy pushing its own wall of water along with it, just exacerbated that situation and made it go over whatever protective measures that New York City had normally had that served them fine. So it literally is this idea of pushing a wedge of water ahead of it. And in most hurricanes, what causes the death and destruction is the surge. They do produce strong winds, they do produce lots of rain, but it truly is that wall of water it's pushing ahead of it that tends to cause the most damage and the most loss of life.
Okay, thank you.
Hi, thank you. This is almost a corollary to Paul's question. And I know you don't want to talk about the future, so my question is about the past. I was wondering, given that normals were sort of 30-year blocks of time and there's been 10 years since the last set, within that 10 years compared to the previous 30, have you seen changes both, I suppose, in a curiosity sense, with a band of latitude just north and or south of the equator? But more significantly, has there been a change in when a tropical hurricane becomes extratropical and then bumps into a mid-latitude cyclone and the tracks thereof? Has there been any sort of change, diversion, intensity over that in the last 10 years that we haven't perhaps seen in the previous 30?
Yeah, I think Chris Fogarty and Bob Roche are the experts in this stuff. And in what they've provided me and in readings that I've done over the last number of years, there still seems to be a huge debate going on within the hurricane community as to the impacts that climate change is having on frequency and intensity, storm tracks and things of that nature. Is this within the bounds of what would happen normally? Is this outside the bounds? I think the issue we're dealing with is the last 10 years probably isn't a long enough period to make any real statements on that. But I think what Sandy did was it reminded, especially the Americans, of the vulnerability of a number of their largest cities being along the eastern seaboard. And in some of the articles I read on the internet, they were talking about Shanghai and some other international cities that are also on large bodies of water, having serious thoughts about what are their mitigation steps that they could take and what could we do to minimize impacts of storms like this. While an occurrence like Sandy is relatively rare, even one Sandy is one too many. So to know that we could go another X number of years and not really have this type of event happen exactly the same isn't to say that something similar couldn't happen further south. When Hazel made landfall, it was more down in the Carolinas, worked its way up from there. This one, landfall in New Jersey, worked its way inland from there. So these trajectories, even slightly different ones, could have significant impacts. Even if something came on shore a little further south, but tracked up along, say, east of the Appalachians, east of the high terrain, that's again over that 20% populated area of the U.S.
Thank you. But when you say Sandy, are you referring to just the tropical cyclone, or are you referring to it bumping into a mid-latitude?
Yeah, I think we're talking about the whole package. I think we're talking.
So how many of those whole packages, greater or small, obviously smaller, have happened in the last 40 years?
Well, I think they're saying that there's been there were 3 others besides Sandy. The Long Island Express in 1938, Hazel in '54, and there was one other in the '50s that had this track that was dramatically different. We saw in the image that showed historically over 100+ years, the deep red, the favored track is the Gulf Stream is staying out over the Atlantic. But we do know that a small percentage does make the more inland trek of real notable ones. And in all those cases, the Long Island Express, and we're starting to transition. So it's difficult to separate to say, was it a true hurricane? Had it already started to transition? I think we need to consider these storms as a whole to say that it may begin its life with tropical origins, but has the potential to morph into a combination or go all the way the other way, but still retain some of that tropical stuff inside of it. We need to deal with those storms as an entirety, not just say we're going to worry about landfalling hurricanes or we're going to worry about large transitioning events. Yes?
It seems that in the case of Sandy, appears anyway that there was a large political motivation in downgrading it from a hurricane to a tropical storm, just moments before it hit landfall. And I think that I don't really clearly understand the definitions as to, like, I understand how a storm transitions, but where do you draw the line? Precisely, has that definition changed in the last 5-10 years? And my understanding, even as the storm was coming across, I know it was starting to change in its shape, but it was still building. And how could it? And part of that definition, I think, is where is the storm taking its energy from? Is it taking it from the atmosphere, or is it taking it from the ocean?
Right.
And if it was still building as it was coming ashore, it seems pretty clear to me there was still a lot of energy coming from the ocean, so how could you say it was not a hurricane?
I think what they took it as, and in talking to Chris and Bob, and also seeing some of the stuff that's come out of the Hurricane Center and the National Weather Service since then, there are some in the hurricane community that were saying that that transition was almost completed after gone through the Bahamas. That what we're actually seeing coming north of the Bahamas had more characteristics of a extratropical or mid-latitude storm than it did of a hurricane. And so this idea that the National Hurricane Center continued to track it for as long as it did, calling it a hurricane, is actually being questioned by some in the hurricane community. And they felt part of the reason they did that was to keep it in the headlines, keep it in people's minds. And then as it became closer to the eastern seaboard itself, the National Hurricane Center, basically in coordination with the National Weather Service offices in that area, said, we no longer have enough justification to call this a hurricane. It no longer possesses enough characteristics to be a hurricane. And it led to some confusion on the part of the people in the U.S., because what you were doing was, if you were watching it on the National Hurricane Center website, you would see hurricane watches and warnings issued for the Carolinas as it went by. As it got closer to New York and New Jersey, there were no watches and warnings being issued by the National Hurricane Center, because they were confident by the time it got close enough to make landfall, it would no longer be a hurricane. So the onus then was on the local National Weather Service office to issue surge warnings, rain warnings, and wind warnings. And so you had to plug into kind of your local meteorologist to get that information. So the debate will probably continue as to when this transition took place, what was it when it made landfall. But at the time, and in going back and seeing the discussions now, there seems to be some evidence to say that they even kept calling it a hurricane beyond, the point at where it had already almost completed the transition. The difficulty lies in, as mentioned in the earlier slide, is even after a storm is transitioned, it can still retain those tropical characteristics in some parts of the storm for a long period of time. And so the idea, as you said, well, it still looked kind of like a hurricane and still had tons of rain, still had tons of wind. Aren't you splitting hairs to say it was or it wasn't a hurricane? But there is set definitions. They're looking for symmetry. They're looking for the way the wind field is set up, the way the rain bands are set up, and it did start to become more asymmetrical and more lopsided as it got closer and closer to the shore, which is more a characteristic of the extratropical storms and not a true hurricane or tropical cyclone. But it is going to be a debate that's going to go on for...
Yeah, because the layperson, or even the educated layperson, 73 miles per hour is kind of the distinction between hurricane and tropical storm, and clearly winds of 80 miles an hour
Right.
were recorded all over the place, so that's not even, I mean, it's well above the 73 threshold.
Right.
And you've admitted in your presentation that the central pressure was the lowest ever recorded in that part of the country, and yet so we got wind pressures above the threshold, and we've got central pressures below anything we've seen before.
But we have to be careful. We have to...
It didn't fit with the general understanding.
That's right. We have to be careful that if we're mixing definitions, because what we're saying is, as you mentioned, there is a wind threshold for hurricanes. We start moving from tropical storm to Category 1 to Category 2, but it's winds based on a tropical storm. And we can still have large-scale extratropical storms that generate hurricane-force winds, that generate lots of rain. So what we're saying is, what is producing that rain? What is producing those winds? Is it still tropical in origin, or has it now transitioned to a big, bad, ugly fall storm, which can also produce those types of conditions? And that's where the hurricane forecasters are saying, I was losing the ability to define this as a storm of tropical origin as it got closer. But as you rightly point out, for the average layperson, big winds, big rain, it was a hurricane. What changed? But in the community, at least, the definitions and whatever, where the weather was being generated from, how it was being generated, had transitioned into an extratropical storm, even though the impacts were similar to. I mean, I'm still convincing people that Hurricane Hazel wasn't a hurricane when it hit Toronto. And it's a losing battle, because they just, lots of wind, lots of rain had to be a hurricane. But by the time it hit Toronto, it was just a massive storm with tropical moisture interacting with another big storm to give what it gave. But once it's embedded into the psyche, you can't. And people in New Jersey and Long Island, I'm sure I'd never be able to convince them of a hurricane either.
Geoff, you shared early in the presentation confidence in the forecasts and the capacity to forecast the weather is just getting better with time. Things like supercomputers and better data, and a variety of things have just made it stronger. And you shared with us being able to look 5 days ahead or 7 days ahead or whatever. One of the challenges is the weather has got many, many different dimensions. So this was primarily in the context of telling us about Sandy. So anticipating a hurricane and giving advice about a hurricane. We've probably got several days to talk about this and get ready, but you wouldn't have days to get ready for a tornado. You'd have minutes or a very short period of time. Across the spectrum of things that cause damage, that you were even sharing before the presentation that we've got a real cold snap coming, and we've got a fair amount of warning about this event occurring. So it does depend quite a bit on the weather, the amount of time that we have to anticipate.
And the scale of the systems. And I think your point, I was going to leave everybody with bad news today, because everybody thought this morning was cold. Starting Sunday, you're going to be wishing it was today, because it's probably some of the coldest weather we've seen, not so much individually, but the fact that we're going to string like 5-6 days together of real January weather we haven't seen maybe in 2 winters. It's those patterns that those medium range models do a good job at detecting. So the conversation we were having in the Weather Center 4 or 5 days ago was, boy, that looks like real Arctic air coming down. So we're talking about a massive scale from Nunavut to Manitoba to Ontario to the eastern seaboard of the U.S., as opposed to, as you said, individual clusters of thunderstorms. The ability to say the conditions could be favorable for thunderstorms to form along a cold front, along a feature, is there. But the ability to say those thunderstorms are going to form in the Bruce Peninsula versus lower Michigan is not there yet. So what we're going to try to have to do is to explain to people of possibilities, and then we're still going to get into that granular time frame of, 30 minutes notice, there's a tap on the shoulder, duck, because it's coming, it's a localized storm. But I have to say that, 5 years ago, 7 years ago, a smartphone was pretty expensive. Not everybody had one. Everybody in my family has one now. Everybody I see, even driving, has one. There's a huge ability now, and weather continues to be one of the most popular apps. People want to know what the conditions are. Environment Canada needs to play in that. I don't think we're going to be creating apps, but what our IT guys have committed to doing is providing information in a usable form for the app developers, XML formats and all that, so they can pull the information out and display it. And that's going to be our notification. Goderich was the prime example. Amazing job done by the forecasters that afternoon, but I'm going to be explaining at the coroner's inquest next month, they had 7 minutes lead time. If they'd heard the warning, it was a Sunday afternoon. Did they have a weather radio? Did they have a screen up on their smartphone for warnings? Probably not. So that 7 minutes, the forecaster feel I did my best, I got 7 minutes, but for the average person, they're going to find out about it after it's hit. So we need to use that 7 minutes to the best of our ability. And I'm excited by the fact that this idea of MTO, wanting to play, getting involved in Sandy. Since Sandy, I've seen the MTO signs talking about fog. We've issued special weather statements for fog in southwestern Ontario. It's on the sign. You're driving right now through London, and the visibility is good, but it's saying fog ahead. Maybe I'm going to take the foot off the gas or be aware, at least when I go over the next rise, I may not be able to see it. Snow squalls. It's sunny in Toronto. I'm driving to Barrie. There's no problem. Suddenly you get north of 89, it's a wall of white. Why didn't I know about this? So it's that type of stuff, that using other sources of information, piggybacking, electronic billboards. We're trying to get involved in that. Using mechanisms, people are driving by, a quick icon, freezing rain warning in effect, okay, I'm gonna modify my behavior. And working with folks like Jen Spinney at the University of Western Ontario on the social sciences side. And as we've done with the engineering folks, to understand the damage better, now we need to understand people better. I sent the message, why didn't you do anything? Well, because natural curiosity, you said tornado warning, and I had to look out to see. So we need to find ways to better communicate and get people to change behavior,
and the risk-based approach is just really sound.
The Americans have had some success, and we're going to be looking very closely for studies coming out in the next few months about the past summer. There were some outbreaks of tornadoes that they had that were so classic that they had long lead times on them, and they used very, very strong wording. These will be strong tornadoes, these will be deadly tornadoes, you need to seek solid shelter immediately, and it did seem to have some, did reverberate with those communities who are used to hearing a lot of tornado warnings, but really, really strong language. But if you use that strong language and it doesn't happen, we have a problem. And the forecasters are still a little gun-shy about going to that nth degree unless they're really, really confident. And again, that cuts down on the lead time to reach that level of confidence.
We were talking about the tiered warning system in France. You said you have to be careful about that most extreme warning level. So are there examples in France where they used it and it resulted in loss of credibility?
I think in France, what they decided to do was very cautious. So what they've done is they probably missed a few events that got into the red because they waited a bit too long. They got into the orange, and I think in talking to a guy in Montreal who's been looking at that system, the carte de vigilance system that they use there, they've had something like 8 years of the program, and they've had something like 10 red level events in 8 years for different reasons. By the end of the 8-year period, every segment of the French population knew what red meant. They did interviews with homeless all the way to the richest people in France, and when that red showed up on the carte de vigilance, they knew rare, dangerous, whatever. So they've had more success. Now, when they start verifying the yellows and the oranges, I think that's maybe where more of the misses are showing up, or the transitions they still have to get better at, as to when do I move from yellow to orange and orange to red. But they've really strongly imparted on their forecasters, you must have a very high degree of confidence to use red. We don't want to blow the capital we've built up with people to know that red is action. Red is rare.
The one area where I've seen it be a problem in terms of credibility was the tsunami warning. And sometimes they've got people leaving their homes and business and running up the hills, and nothing happens. And it's happened enough times, credibility was lost. So
right.
There are some international.
And I'll tell you, right now in Ontario with Environment Canada that I've seen happening, long knockdown drag-out discussions in the Weather Centre about whether to go tornado warning. In the old days, you waited until a spotter said, there's a tornado here, and then you went tornado warning. And you got it downstream. If it's going to be long-lived, you've got it covered. Now with Doppler and increased knowledge and how to interpret this stuff and what's going on inside the storm, there's a higher degree of confidence going tornado warning based solely on radar. But still, once you issue the tornado warning, you can't pull it back. And if it doesn't happen, it's the same with the tsunami. I live in London. We get these, I don't know, every other week they've issued a tornado warning. I've never had anything happen here. They may have actually had a tornado at the north end of the city. This person lives at the south end. They saw some dark clouds up there, but didn't have any impacts. It's a bust. But that was within our smallest region that we can forecast for. That's the challenge with these small-scale ones. And then you need to advertise what happened. So you need to tell that person, even though you lived in the south end, you didn't get it. Well, what happened in the north end? And it, went through the subdivision. That could have been you. Oh, okay. So there was a reason you issued it. But if you don't tell them that, it's this tornado warning, and I'm looking and the birds are chirping and the sun's shining and, what are these guys smoking? That's a problem.
I have to tell you where I work with to help you understand my question. I work for the City of Toronto. I am the facilitator of the Weather West Partnership, which is a coalition of about 60 organizations responsible for infrastructure and critical services across the Toronto region. So that group is concerned about extreme weather and adapting to that.
Right.
We have completed the initial stage of a critical infrastructure interdependency study, looking at when one type of infrastructure fails, what happens. So I'm really pleased to see that your new messaging will be looking at impacts. I have been approached by groups in the U.S. that say they have a complex events analyzer, okay? And they say that it will take weather information like you are going to be able to provide, and it will have an algorithm within this computer program and figure out who logically needs to be alerted, that
right.
could actually take action, people in ambulance, fire, police, waterworks, whatever, parks, etc. And I wanted to ask you, are you aware of any of that technology? Because I'd be interested if you have any comments on that.
Yeah, I haven't seen too much in the way. Like I know there is some stuff out there that is integrating information from a variety of sources to come up with hazard maps or risk maps, but I'm not aware in terms of what those algorithms are using to come up with it. The closest analogy I can think of is when we work with the conservation authorities. Environment Canada's responsibility is more to tell them how much rain is going to fall and where we think it's going to fall. Then they take their hydrologic models, plug it into the watershed, knowing their sensitivities, how much rain has fallen in the last few weeks, and then they come up with sensitive areas within the watershed that they may decide to issue a high water level advisory, a flood advisory, or a flood warning. Now, to take that beyond that and start to plug in more complex infrastructure, the program itself would have to know, I guess would have to use radar or some other weather information to a much more specific sense to get it as granular as what you're describing. I haven't had a lot of experience. And somebody saying if Environment Canada issues a severe thunderstorm warning for Toronto, you'd almost have to have the real-time radar plugged into that black box to say what part. Is it Scarborough that's going to see the impacts? Is it, Downsview? Is it going to be East
And
York?
this is what they're saying they would do. They're saying that they would actually be using their modeling, which gets down to smaller pixel size, so that we actually could say, well, yeah, in the west end, mobilize people
Right.
for certain things, and not so bad in the east end.
Well, the model side still got a long way to go, but if they were integrating real-time data and then augmenting it with short-range forecasts and
This
stuff,
is what they're saying.
that would have some merit. And we've seen, what we're working on in Environment Canada, something called forecast radar. So it looks like a radar, as they see, even, I guess, Anthony Farnell and some of the guys on TV at night have something similar. They tell you what's happening right now on the radar. This is real. There's rain here. There's snow there. And then they kick in the computer model, and it takes that and moves it forward in time. Now, in a lot of that stuff, it's smoke and mirrors. It looks pretty on television, and, I think they're just glad nobody verifies them. Since that little green blob didn't go over my place. And but to say that some modelers, our experimental model now is called a limited area mesh model, has a 2.5 kilometer resolution. But we have to be careful because you can have 2.5 kilometers of garbage. When you start going down to that level, you really need excellent initial conditions feeding your model. If your grid is too coarse, giving you the information to feed the model, then you can extrapolate it down to 2.5 kilometers, but you're not going to get a true representation of where that weather is going to be really bad. Now, for big storms, if they're modeling like a big rainstorm or a big snowstorm, you're going to have more success because those storms are a bigger scale. The model is going to perform better. Thunderstorms and things like that, where you're getting down to almost a postal code or block by block type thing, that's still, to me, a work in progress. That you'd probably want to, see the output and see it work in a real situation before you'd be able to even form a comment to say, well, you guys were telling us it was going to go over here, and it actually ended up happening there, and then they'd have to kind of hand wave and do whatever. But once you get really, really granular, that gets to be a problem.
So just a follow-up question, we're also being approached by groups that offer technology for broadcast messaging, and I've seen it in the U.S. where they have way more interrupted TV broadcasts and radio interruptions and stuff like that, and so it makes me think, well, that Toronto needs something more like that so we can get more people aware using technology. So there's this company called Everbright, and they call me every 2 months to say, hey, you going to do it now? You going to do it now? Do you have any comments on that?
Well, I guess it comes up to jurisdiction issues as well. Has the City of Toronto got jurisdiction over any media to actually make them, or are you just doing it on a website? Or because one of the issues we deal with is in the States there's legislation that says thou shalt broadcast these things. You'll put the red banner on and you'll do it. In Canada, again, we're consensus and we hug each other and there's lots of meetings. And the other issue we're dealing with, even in the States now, the challenge is, what are you watching? Cable, satellite? I was watching CBC Vancouver last night. So are you going to scroll a banner for Toronto over CBC? Are you going to know enough to know that my box is watching another? So there's issues with, I think it's a great idea, and I think the scrolling banners are another way to reach people. But the best idea I've heard that hasn't gone anywhere yet that I'm aware of was a guy was going to put it in the remote control. He was going to put a little screen in the remote control. He was going to put a vibrator and a siren in the remote control. And if you had a warning for your area where the remote control has GPS, it was going to dance around your coffee table and scream at you. And the only reason it would do that would be weather. So you don't get the kids, we're going to the basement. Anything that's on the screen, it's complex enough these days because, again, we've got a society that's pulling information from so many sources. I don't know if you're watching your local news. You could be watching a movie on demand. You could be doing something else. How do I interrupt? So we've got to go down to the box, and that means it's Rogers and Bell. And City of Toronto, it'd be great if you guys say, please broadcast this, but I don't know who does Everbright work with to make it happen.
There's also questions about who has the right to issue legal warnings. There are legal implications, there are insurance implications, and there's accountability issues as well. I know there's a bit of a controversy in the States recently where the Weather Channel down there started naming winter storms.
Yeah, but did they? Have you guys seen one? Have they named one?
I don't know, but they do that in Europe. But the thing is, do you want a private company doing something that is traditionally the territory of government, and what's the fallout of that, the potential fallout to that? I mean, Geoff just said that he's going to a coroner's inquest on Goderich. And is this company going to come up and go to a coroner's inquest and talk about how they issued this warning or failed to issue the warning or issued it wrong, or there are all sorts of these things?
I would hope Everbright, I mean, in the same way they probably do in the States, they're probably pulling Environment Canada's messaging. I'm hoping they're not generating their own. But even saying that, the issue is, did Everbright have a problem with their control center? Did the guy fall asleep at the switch? I mean, those types of things are going to come up. But if they're basing it on EC messaging, I'm pleased as punch to have as many other third-party people jump in. Like this guy that we're talking about with the electronic billboard, he's interested in doing it. We're working now to get him the icons, and he's triggering it on. He's got a control center someplace buried in a bunker in the US where this guy watches electronic billboard messaging across North America, and he can change messaging on billboard 47-2 in Phoenix or 68-5 in Seattle when the message comes in, and he's able to automate it. So he's telling me it's 8 minutes turnaround time from receipt of an EC warning to broadcast on the billboard. Now he hopes to have it down to 2 minutes lag time from receipt of message to billboard.
One of the tests I use is which ones of these groups come to ICLR and ask for a legal opinion on how vulnerable they are if they get into this line. So Environment Canada came and they asked for an opinion, but I haven't heard of Everbright.
I mean, they were, I think the point there, they just had the technology, they weren't going to make the decision. That was, and to your point, Glenn, so, I mean, who's actually making the decision to press the button and say, yeah, do this?
Well, and the other issue we've got in Canada and the States too, I guess, is for radio. Almost every radio station goes into syndicated broadcasting mode in the evening and on the weekends. So we issue a tornado warning diligently, give an amazing 45-minute lead time to Sault Ste. Marie. Everyone's listening to the local station, but it's on autopilot, and there's no way to break in. So again, trying to negotiate, we'd like to send you a WAV file that you could stick into your broadcast automatically, but you have to negotiate the rights to do that. How often are you going to replay it? Are you going to do it during commercials? So there's issues. The technology is there. I mean, we have a message. It's 120 characters, and we promise it won't go longer than that. You decide. There was negotiations years ago with media that said for certain types, tornado warnings, severe thunderstorm warnings, it would be repeated frequently, X number of times an hour. For things like a freezing rain warning or a winter storm warning, maybe just once an hour, because it's still 6 hours away. So we understood we're not going to overwhelm a private entity's broadcast, but for certain types where you only have 7-minute lead time, I'd like to hit it, and hit it a few times as soon as the message goes out. So those talks are still there, but I haven't seen it materialize.
Yeah, when my car was written off and my wife was pummeled by hail, with bruises 3 years ago, yeah, it would have been nice to have some warning.
For what it's worth, any personal opinion is valueless, but given and in reference to what you were saying, I'm wondering what EcoAlert is going to do. When Sandy came through, I mean, traditionally every day I look at the EC weather page 3-4 times a day for Toronto and for where I live, Toronto. And I really appreciate the fact that it's updated every hour, well, early hours of the morning, maybe not always, but every hour of the day, and that makes a big difference. I also look at Met Office UK, and I was watching the Hurricane Center for Arab States when Sandy was developing, so I saw the initial forecast and so forth. The thing that is missing for me is, yes, you've got point accuracy, but I go to another web page which is shows the output of a weather research, WRF, Weather Research Forecast Model out of the States, but employed by consultants in Toronto and Senes. And I look at that because they're showing me the pattern of wind direction, so I could clearly see it coming down from the north far more easily than I could guess from the point data I was getting from Environment Canada. So what I'm really trying to say is that, and I'm an old guy, right, hopefully getting older, but the old isobars and fronts in black and white were great. When we invented color and put blue and red on top of them, it was an improvement. And yes, now you can get motion moving into them as well, and Met Office UK do that very well. So does the fresh thing. Point I'm trying to get to is when on the Sunday and the Monday, and especially on the Monday when I was looking at it, I was looking at the forecast, which is albeit I think they put them out about 2 o'clock in the morning, and they do a longer term one at 10 o'clock in the morning. So I think I was looking at one that was about 28 hours old. And it was still close enough, but given how things were happening so quickly, I was then verifying it by looking at Environment Canada's website. What is the temperature now? What is the wind? What is the speed? Blah, blah. And I got a pretty good picture. Right. The point I'm trying to get to at the end of this is, if Environment Canada were to go back to the old system of providing isobars, fronts, and using the modern system of showing how these things can change over time, albeit with a qualifier saying only as good as the last time it was printed, as it were, right. I think you really have something. And that eco alert me to people that really want to know and have some reason to know and ability to understand these things. I think providing a greater level of early warning, very simple, is great, but linking that to something that's going to give them a better understanding of what it really means, right. As opposed to having to wait for the next hour one to find it, et cetera, et cetera, et cetera. I think that would be very valuable. Yeah, and the graphic side of things has been talked about a lot in our, I mean, the maps are there on our website. They're not easy to find. It's almost impossible to. Right. They're not too user friendly. And I think a picture, and again, a lot of folks may not even be the isobars, but even just the graphic that shows this is the center, here's the circulation, and bigger wind arrows mean windier and smaller. We have to think of the general audience, but yeah, having a scale idea of how big this thing is, how close it's getting, definitely has merit. And the pattern of its movement, right, which you can get much better from that.
Are Canadian Dopplers currently being upgraded like they are in the States?
We've, 2 in Canada are the new dual polarization that's further ahead in the States right now. So King City, north of Toronto, and McGill are both dual polarized, and that is the next leap forward. There was conventional radar in the 60s and 70s that told you how hard and whatever it was raining and where it was raining. There was Doppler. Came up in the 80s and early 90s, which said, what are the raindrops and snowflakes doing inside the cloud? And now dual polarization is the next leap forward, which instead of the side scanning what's going on, it actually scans in both directions. So you actually get the size of the snowflake, the size of the raindrop, helps in precip amount forecasting, helps in hail forecasting. There is a plan in place. Some of the Canadian radars are easier to transition to dual polarization than others, and they will be probably first on the list. But Minister Kent did set aside a budget to do the upgrades, and my understanding is at least 2 additional radars, I think Exeter and Brit in Ontario, are of the type that can be more easily upgraded. They're on the slate in the next couple of years to be upgraded, and then that transition will go across all 33 or 34 radars across the country. And we've had a lot of success. King's been dual pol for I think almost 2 years now. Freezing rain events has been very helpful in terms of looking at the depth of the freezing rain. Hail events has been very helpful. So there's a lot of excitement for this next generation, if you will, of radar coming, and that'll only help us do our job. Yes?
When you were talking about Hurricane Sandy, or not Hurricane Sandy, you mentioned that the National Hurricane Center had kept jurisdictions until a point, and then it got handed off to the local weather office. Is that the same relationship as Environment Canada?
Yeah, exactly.
Who owns the storm,
yeah,
and who makes the announcements?
What we had in the States was similar to what we had in Canada. It wasn't so much that the National Weather Service suddenly started issuing the surge warnings and the rain warnings and the wind warnings. Those had been issued with a long lead time as well, but the focus seemed to be, and even my focus, was I was going to the National Hurricane Center site while it was being called Hurricane Sandy, and I was watching the track, and I wasn't really paying attention to the local warnings at that point. By the same token in Canada, it is that exact relationship. Now, the only real place in Canada that you're going to get a true hurricane is Atlantic Canada. That the chance of a true hurricane whacking Nova Scotia, PEI, south shore of Newfoundland. But the beauty of our case is the local office is co-located with the Hurricane Center. So the Hurricane Center is in one part of the Dartmouth office, and the next door is the center responsible for the wind warnings and the marine warnings and things of that nature. So the cross flow between those two is not only it's not a phone, it's literally walking over to the guy saying, what are you doing in the tropical cyclone statement or the hurricane statement? This is what I'm going to do in the public version of that forecast. So that coordination is there. And I think with Sandy, it was more the fact that it was billed hurricane, 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 and then an hour before landfall, it's not a hurricane. And a lot of folks were sort of, because they were looking at the National Hurricane Center site going, well, where's that red piece of coastline indicating there's a hurricane warning out for New Jersey and Long Island? But they made that decision actually hours and hours before to say that they were confident it would have transitioned by the time it got close enough that they were going to leave it with the local National Weather Service office. But as was mentioned earlier, for the layperson, what did that mean? We can sit here and split hairs as meteorologists. That was the procedure, and we followed the procedure, but did the message get out in the intended way? And I think that's why National Weather Service and Environment Canada will be looking at Sandy from the messaging aspect. Was there a different way this could have been done? And on the off chance we could see another transitioning landfalling storm in the coming years, what are the lessons learned in terms of messaging, responsibility, where people should have gone?
My follow-up question, if I could, is in the U.S. I understood, and I actually looked, and one website stopped. You had to kind of go to another place to get the continuing story.
Yeah.
Environment Canada, are you set up that way, or?
Well, in ours, it would probably make reference in the statement, like our Weather Office website is where both the hurricane statements appear and the other forecast information, the warnings, and the radar. So it is more of kind of a one-stop shop. In the U.S., it is a separate entity. So the National Hurricane Center, located in Florida, is doing this for all of the U.S., and the local offices are, as you said, a different website. You'd have to, click here for more information and be bounced over, whereas within Environment Canada's Weather Office website, it would just be another part of the website. Okay, now I want to drill down. I want to know what the impact is in Halifax. I'm going to go to that direct Halifax page. So it isn't sort of sending you to another website, another entity. It's all within that umbrella of Environment Canada.
No more questions? Okay, well, let me wrap things up. Please join me in thanking Geoff for a really informative and detailed presentation on Sandy and the activities that Environment